This is a pre-built version of the application. So let's go ahead and run it. And we can get data from one of three places, either hard-coded or from the database or from file. And from file, we get it from either one of those three files. So they are JSON files. So this one has three round trip flights. So this airline, so this trip have this outbound flight. So it takes off at this time, it lands at this time, and stays on the ground this time, this number of minutes. And the returning flight take off at this time and lands at this time and stays on the ground for this number of minutes and is ready after that for another round trip. So if we select the file here, we have those three airlines, and let's pick up this one. So here we have those five trips, the outbound flight and the inbound flight, returning flight. And this is where we have the domains that are available for us. So we can use either 3 planes, 4, 5 or 6 planes. So let's go ahead and use 3 planes. And we end up, so each trip, based on those data, those timing, we deduce that we have those concurrent trips with this trip, and this round trip flight have those concurrent round trip flights, and same for the other 3 here. So the constraints that we have are that this trip must be assigned different plane from those other 3 trips. Actually, this one from those other 2 trips, and this one from those other 2, same for this one, and finally this one from this other trip. So we're using 3 planes, and the implicit constraints is that adjacent variables must have different values, and the values are the variables are trips, and the values are the planes that are assigned to those round trips. The domain that we are using is those 3 planes. And the solution will have a list of trip equal plane assignment satisfying all constraints. And we will be using the backtracking search algorithm, so depth first search, plus considering assignment to a single variable at each step, plus considering only values which do not conflict with previous assignments. So let's go ahead and do that. So we end up with this trip assigned this plane, and the concurrent trips will not be assigned the same plane. Same for this one. Here we have different planes, and same for the other 3 here. And next, let's go ahead and use data coming from database. But before doing that, let's go ahead and create the database. So this one will create those 3 airlines with those round trips. So this one, this table, and this table will have those round trips, and this table will have those 7 round trips. Now if you use data coming from the database, and this is the database that we just created, so we have those 3 airlines, and let's pick this airline, and it has those 7 trips or round trip flights, and let's go ahead and use 4 planes for those. And same thing if we display the variables. So based on those trips, we concluded that we have those concurrent trips for each one of those. So we have those constraints. And we are using 4 planes in the domain. So let's go ahead and do the backtracking search, and we end up with those assignments. And we can do hard-coded data. So that data will be coming from here. So here we have the hard-coded data, the outbound and the inbound flights. The outbound one, and this is the inbound one for each one of the 3 airlines. And we'll go for this airline. So we have those 9 round trips, and if we try it with 5 planes, and do the backtracking search. So no assignment solution found. So maybe try with 6 planes. So same thing, we'll do hard-coded. Actually, let's run in verbose mode to see all the steps. And same thing, we'll do hard-coded, and go with this airline. It's 9 round trips, and we'll try with 6 planes. So we end up with those concurrent trips and those constraints. And we have 6 planes in the domain. And if we do the backtracking search, so here we're going through all the steps of assigning planes to flights. And we end up with this solution. So let's quickly go through the code. So we have this trip class, which represents a round trip including outbound and returning inbound flights, and it includes logic to check for and process concurrent trips. And this one represents a flight including takeoff, landing, and time on the ground. And this class contains a list of hard-coded trips, meaning round trip flights operated by various airlines. And this class prompts the user for file, table, or hard-coded data source, and it prompts the user for domain and variables selection, and picks up and return a map containing the flights and their concurrent flights or round trips. And this class represents a variable, meaning a round trip flight in this case, and it keeps track of a list of concurrent flights, and keeps track of a list of derived constraints associated with this variable or round trip flight. And this class represents a constraint between 2 concurrent variables that must use different values, and it contains logic to check for this constraint. And this class contains code display functionality, and it displays initial information, trips initial data, and a derived list of constraints, assignment solution. And this class contains constraint satisfaction problem, flight scheduling logic, and it keeps track of lists of flights and domain values to be used, and it checks if the domain values assignments are compatible with the constraints, and it uses recursive backtracking search algorithm for domain values assignments. And this does what it says, so it finds the constraint satisfaction problem assignment solution, and this one prompts the user for data source options, either from file, database, or hard-coded, and it picks up variable and domain data and triggers the finding of a CSP assignment solution. Now the code will be available for download, and a step-by-step version of this will be available for viewing by channel members at the senior software engineer level and above.